waiting for my car to heat up. I know I should probably be driving it for it to heat up, but I want an excuse to make a fucking little video. So I have a C++ project, and it is multi-threaded, and I have it's a game engine. So I want for certain classes to have the ability to handle inputs and events and shit like that. And the way I've decided to do that is I've made an interface class, an abstract class, with just one function that is called like input or event, and then it takes a specific event pointer or an input event pointer, and then that's set to equal 0, so that way you have to implement it if you inherit that class. But then if you want to, handle inputs, you inherit that class, and then those classes inherit a base class that has a static vector of base class pointers, and then it has, of course, a constructor and a virtual destructor. And the constructor adds the keyword this, so the pointer, to that vector. The destructor iterates using a range-based for loop, iterates over the vector, and then when it finds itself, it erases itself. Now, this was working fine before, but I think it was working fine because I accidentally... wait, that doesn't make any sense because they weren't inheriting from it anyways. Okay, well then I don't know why it was working before and now it's not. But now it's not. Now it's crashing when I quit the game engine or the application, and it's a heap use after free, and I think I know why. It looked at first like the destructor was getting called twice, but that's like impossible as far as I know. And I think it was just that two destructors for that type were getting called at around the same time because of the multi-threading. And that's when I realized, oh, at first I thought it was that, somehow the object was getting destroyed, but then it was also trying to access itself, and I don't know, it was like a null pointer exception or some shit. No, that was stupid. I think the actual problem is a race condition, because it's multi-threaded, it's going to be a race condition, and I think the problem is that while one object is iterating over the vector to find itself, another object has just erased itself from the vector, and that invalidates the iterators for that previous object. Now, there are a lot of solutions that you could use. I tried a quick one. I tried implementing a quick static boolean, busy, if busy, or I'm sorry, do while busy, and then busy is true, do your shit, busy is false. Obviously that's not going to work because it's multi-threaded, and it's not a great solution. It's not a mutex, it's just a fucking boolean value. So I don't know the exact specifics, but I do know that that's not a good solution and that's not going to work. And it didn't work. It still, the crash still happened at the same spot. It could be, by the way, it could be unrelated. I didn't check if I was inheriting an old version of the class that I forgot I had lying around and I didn't delete, because it seems to be from one specific class that inherits from it. But I don't think that's the case. I don't think it's anything weird. It could be, but I don't think it is. I do think it's the invalidating the iterators. Anyway, I'm sorry. So I tried that solution, and obviously it didn't work. So I've just thought of a solution that should work, even if it's not great, even if it's actually objectively a bad solution. I'm going to, instead of using a range-based for loop, I'm just going to use an index-based for loop. The old, size t, I, curly brace to 0, I is less than vector.size plus I, because we're using modern C++ and C++ 26. I mean, actually, that would be an argument for using I++ instead of ++I. But fuck you. I'm fucking nerdy hipster and I have to use plus plus I because it's more performant. Even though what I'm about to say is throwing that out the window. Because in the for loop, you will just iterate over the vector, and then if the vector size changes because another object erases itself in the vector, who gives a fuck, you know? It's an index-based for loop. It's just using a number and then accessing the vector when it needs to. So who cares? Well, if the size does change by shrinking, or actually if the size changes at all, and then, you know, the first object thinks it has the index number, but right before it erases itself, the size changes, it now either erases something else, or, even worse, we get a index out of bounds error and a crash. So what's the solution to that? Just check. Just check. Right before you erase, just check. Every single time. Every single iteration in that for loop. Just check. You know, check the size of the vector, check the position, check that the pointer is actually the pointer that you want, which you're already going to be doing, so actually, you know, that's kind of redundant. But just check that the size hasn't changed. Actually, store the size value, then do the for loop, and then compare the size values. Now you know if it's changed or not. That's a terrible way of doing things. It's a completely, like, non-performant, terrible way of doing things. But it might work. I mean, you know, it's multi-threading, so it still could fail. And the performance cost is, you know, but this is a function, I'm sorry, this is a destructor that gets called not every frame, not every tick. It gets called, like, I don't know, fucking whenever the object gets destroyed, and they usually don't get destroyed all that often, right? I mean, you could put it on something that gets destroyed every frame. You could put it on an object that gets created and destroyed every frame. But at that point, I think the construction of the object and the destruction of the object, regardless of what you're doing with the vector, is going to, like, cause more performance overhead than testing the vector every iteration of the for loop. Especially because the for loop's probably not going to be, like, the vector's probably not going to be bigger than, like, my guess would be, like, I think it would be under 1,000 objects. Worst case scenario, like, I don't know, 2,000 objects or something. Actually, no, you know what? You could spawn a lot of fucking entities. It could be a lot. I don't think it's going to cap the vector. And I think if it's, like, under half of, like, the size of a long, I think it should be fine. It's not a big of a deal. I think it should be fine. And again, like, if you're destroying this shit, if you're creating and destroying this every single frame, I think you have bigger problems to worry about. So yeah, I haven't implemented this solution yet, so we'll see if it works. If it doesn't work, the last solution that I have in my head is recompile the entire project and see if that magically fixes it, because that has happened before. It's C++, so, you know, that could work. It's C++, modern C++ with multi-threading, so that could work. 100% that could work. But yeah, thank God for LLDB, but more specifically, address sanitizer. Sanitizer. Address sanitizer. If they didn't exist, I'd kill myself. Yeah, anyway.